Hey class, this is Mrs. Anderson here. This video is going to go along with Unit 11, Section 11.3b. It's going to be all about reference angles. So our objective is that we can find the value of the trig function of an angle greater than 90 degrees using a reference angle. So first, what is a reference angle? A reference angle is an angle, it's an acute angle. So remember, acute angle means that it's less than 90 degrees. It's formed by the terminal side of an angle and the x-axis. So it's always with the ending side and the x-axis, and it's always less than 90 degrees. So we're going to look at a few examples first of just finding the reference angle, and then using or why the reference angle is important. So using it to help us evaluate some trig functions. So finding the reference angle for number 1 here is 140 degrees. So first you start with your vertex at 0, 0, and the positive x-axis is your initial side. And if we want positive, we got to go counterclockwise 140 degrees. So just about like that. So here's our theta, 140 degrees. Now the reference angle is formed by the terminal side and the x-axis. So here's my x-axis, and there's my terminal side, and it has to be a acute angle. So if you went from the terminal side back to the positive x-axis, that'd be 140 degrees. So that's not acute. So the reference angle will be the terminal side to the closest x-axis, which will give me the acute angle. And now I can figure out what that angle is if I think about the whole distance from x-axis to x-axis is 180. So 180 minus the 140 I already have drawn leaves me with 40 degrees. So the reference angle for 140 is 40 degrees. If I want to find the reference angle for negative 3 pi over 4, this is in radians. So if I want to find the reference angle, it would be helpful to first change it to degrees by multiplying by 180 over pi. So I can cancel out the pi. Now 180 is the same thing as 4 times 45. So I can take out a factor of 4 from each. And then negative 3 times 45 would be negative 135. And if I want to draw the angle negative 135, you start at the positive x-axis, except for that you go clockwise, negative 90, and a little bit further, we about negative 135. And then it's going to be, the reference angle is going to be formed by the terminal side, so where the angle ended, and the closest x-axis, which again would be the negative x-axis right here. So it's this angle that's the reference angle that I'm looking for. And we can use the little theta with the comma above it to denote that. And to figure out what that is, again, I know from this straight line forms 180 degrees. So if I take 180 minus 135, I'm going to be left with 45 degrees. So my reference angle is 45 degrees for that one. And if you wanted that in radians, it would be pi over 4. So let's just practice a couple more. Negative 130 degrees, positive x-axis is my initial side. Go clockwise to be a negative angle. So this would be theta is negative 130 degrees. My reference angle will be the terminal side and then the closest x-axis, which is right here. So what is this angle? Will be my reference angle. Again, it's 130 out of a total of 180. So 180 minus 130 gives me 50 degrees. So this reference angle for 130 is 50 degrees. 5 pi over 6 is in radians, so if I wanted to convert that first to degrees, multiply it by pi, 180 over pi, can cancel the pi's. 180 is the same thing as 6 times 30, so I can take out a factor of 6 from each. Then I'm left with 5 times 30, which is 150. So this is 150 degrees. So positive, starting at the positive x-axis, go clock or counterclockwise, 150, and then it's with the positive x-axis and the terminal side, and that would leave me with 30 degrees here, since the whole thing around needs to be 180. Do one more just so you see one that doesn't maybe look the same as those examples. How about if we did like theta of 300? So that would be all the way around down here. So this time the positive, or the closest x-axis would be right here. And to get back around, it'd be another 60 degrees because the whole way around is 360. So my reference angle for 300 is 60 degrees. If I did an angle of, let's say, negative 270, or negative, actually we'll do negative 240. So that's going to be way up here, because negative 270 would be right here. So this reference angle is actually right here, the terminal side and the x-axis. So that one I'm going to take 240 minus 180, and it's going to be a 60 degree reference angle. So the reference angles look different depending on where the terminal side lies, but you always go back to the closest x-axis, and it's always going to be an acute angle, so an angle that's less than 90 degrees. And it's always with the x-axis, which is the horizontal axis. So why are reference angles important? Well, they have an important quality that the trig functions and reference angles have the same values. So for example, if I want to evaluate the cosine of negative 150 as an exact answer, I'm going to draw cosine, I'm going to draw 150 degrees first. So I'm going to go clockwise, and it's going to be right about here. Then, if I know my cosine of theta, I know that cosine of my reference angle theta are going to be equal, but the sign might be a little bit different. So cosine of theta and their reference angles are equal. So the reference angle here would be, I need another 30 degrees to get back to 180. So I have a reference angle of 30. So if I can figure out the cosine of 30 degrees, that will tell me the cosine of negative 150 degrees. And I can use my right triangle to figure out the cosine of 30. So I have 30, 60, 90 triangle. So a ratio of 1, square roots of 3, 2. And cosine from, if you think about SOHCAHTOA, cosine is adjacent over hypotenuse. So on a cosine of 30 degrees, so adjacent is the adjoining side. This would be the opposite, and then the 2 is the hypotenuse. So cosine of 30 is going to be adjacent over hypotenuse, or the square root of 3 over 2. So that means that the cosine of negative 150 degrees is going to be the square root of 3 over 2. The last thing you just have to check is which quadrant does it fall into. Remember that acronym we learned where it said all students take calculus? Which means in the first quadrant, all of them are positive. In the second quadrant, only sine and cosecant are positive. Third quadrant, tangent and cotangent are positive. And the fourth quadrant, cosine and secant are positive. So since the terminal side of this angle ended in the third quadrant, our answer is going to be negative for cosine. So cosine is negative in the third quadrant. So that's the last thing we have to check. So cosine of negative 150 degrees will be negative square roots of 3 over 2. All right, so let's try another one. So sine of 120 degrees. First thing we're going to do is draw it out. So 120, go counterclockwise. So draw the angle. Then find the reference angle. So then find the reference angle, which is an acute angle with the x-axis. So it'll be that angle right there. 120 plus 60 degrees gives me 180 to make that straight line. So now, then I can find the sine of that reference angle. And then I'm going to check the sine, like sine positive or negative sine, different type of sine for that. So I can use the 30, 60, 90 triangle again since I want the sine of 60 degrees. So 30, 60, 90, across from 30 is 1, across from 60 is the square root of 3, and across from the hypotenuse is 2. I want the sine of the 60 degree angle, so this will be my opposite side. This one's my adjacent side, and this one's my hypotenuse. And sine is opposite over hypotenuse. So sine of 60 degrees will be opposite square root of 3 over hypotenuse of 2, which means that the sine of 120 degrees will be the square root of 3 over 2 as well. And if I think about my quadrants, all students take calculus, so this lies in the second quadrant, and sine is positive for all trig functions in the second quadrant. So that means sine of 120 is a positive value of square root of 3 over 2. Okay, I want the cotangent of 4 pi over 3. So if I want given in radians, so I'm going to change it to degrees first. So 4 pi over 3, and I'm going to multiply by 180 over pi. So I know that 3 goes into 180, 3 times 60 is 180, so I can take out a pi and a factor of 3. Then 4 times 60 will be 240. So really I want the cotangent of 240 degrees. So I'm going to draw out the angle first. So it's positive. So you're going to start at the positive x-axis and go counterclockwise. Remember this is 270 down here, so that's 240. It's 180. And then the reference angle, so I drew the pink angle here is 240 degrees. The reference angle is going to be with the terminal side and the x-axis. So it's the one that makes the acute angle, so right there. So all the way there was 240. Back to the x-axis is 180. So if you take 240 minus the 180, you'll be left with 60 degrees. Yep, 60. So that's my reference angle. So if I find the cotangent of 60 degrees, that will give me the cotangent of 240. And I can find the cotangent with the 30, 60, 90 triangle. 1 square root of 3, 2. Remember SOHCAHTOA. Tangent is opposite over adjacent. So that means that cotangent of theta will be adjacent over opposite. So I wanted 60 degrees. So this one's going to be my opposite side, adjacent side, and hypotenuse. So cotangent of 60 will be adjacent 1 over opposite square roots of 3. Now we're going to multiply that by the square root of 3 on top and bottom so that we have it rationalized. So that's going to give me the square root of 3 over 3. And then the last thing I'm going to do is just to check if that will be a positive or negative answer. So cotangent of 240, 240 degrees the terminal side lies in the third quadrant. All students take calculus, so the third quadrant is the tangent quadrant, which means that cotangent is also positive. So square root of 3 over 3 is my final answer. 3 pi over 4. So 3 pi over 4, multiply by 180 over pi. I know that 180 is the same thing as 4 times 45, so I can take out a factor of 4. I can take out a pi. 3 times 45 is 135 degrees. So drawing positive 135 degrees brings me into the second quadrant. So my reference angle is going to be 135 minus 180. Take away that 135, leaves me with 45 degrees. So that's my reference angle. So now I can find the cosine of 45 degrees, and that'll be equal to the cosine of 135 degrees. So for 45 degrees, you need to use the 45, 45, 90 triangle to get the exact answer, which has a ratio of 1 square roots of 2. And cosine, again, is the ca, so it's adjacent over hypotenuse. So adjacent and hypotenuse if I use this angle here. So cosine will be 1 over the square root of 2. Now I'm going to multiply both the top and bottom by the square root of 2 in order to rationalize it. That's going to leave me with the square root of 2 over 2. And then we are in all students take calculus. So we're in the second quadrant, which is only positive for sine, which means my answer for cosine of 135 degrees is going to be negative square roots of 2 over 2. Now the cosine of 45 degrees is positive square roots of 2 over 2 because that would lie, 45 degrees is in the first quadrant. So all trig functions are positive. So the cosine of 45 degrees and the cosine of 135 have the same trig value, the square root of 2 over 2, but the 135 is going to be negative square roots of 2 over 2 because it's in the second quadrant versus the first. The last one I have here is for the tangent of pi over 2. And then we can easily change that one to degrees. If you remember, pi is 180 degrees. So pi over 2 is one of those ones you should maybe memorize as 90 degrees. So I'm looking for the tangent of the 90-degree angle right here. And to find a quadrant angle, we have to use that unit circle idea where we put a point on our axes. And so I'm going to go, it's over 0, and I'm going to pick up 1. That way, if I pick up 1, if I think about my unit circle, I have a radius of 1. So I have the point 0, 1 as my x, y, and a radius of 1. So anytime you have a quadrant angle, you do need to use this idea. Remember, you could also solve for r using that quadratic or that Pythagorean's theorem. It's the square root of x squared plus y squared. That's how you could get r as well. But if I pick 0, 1, I know my radius of my circle will be 1. Then I use the idea of this triangle. So I put my theta right here. I drop it down. I know this is x, this is y, this is r. And then tangent of theta would be opposite over adjacent. So it's going to be opposite over adjacent, which will be y over x. So this particular one is going to be 1 over 0. So the tangent of 90 degrees is actually undefined because it's 1 over 0. And you could find all of the trig functions if it wanted you to, like the sine of theta or the sine of 90 degrees then, for example, would be opposite over hypotenuse, so y over r. So y is 1, r is 1, sine of 90 would be 1. Cosine of 90 degrees is going to be x over r, which will be 0 over 1, which is then 0. And so in the next video, you're going to see how these 1 and 0 correspond back to our ordered pair of 0, 1 as well. But this one asks specifically for the tangent of 90, so it was undefined. All right, that's all I have for this video. Thanks for watching. Let me know if you have any questions.